We have a few different types of problems in the opener today. First one is like the ones we did yesterday where we're solving equations that have square roots in them. That'll be good practice with what we did yesterday. The second one doesn't have a square root, but it has a square in it. So we're going to do this one pretty similarly, except there's going to be, one big difference with this one, and we'll talk about that when we get it. And then this is a review from stuff we did last triad with simplifying square roots. All right, so let's start with this one, solving the equation with the square root in it. We're going to start this just like we always do, circle the variable, draw the line of equality. But then there's one more thing that we're going to do since this equation has a square root in it, which is what? We're going to put a box around the square root. All right, so we circle the t to remind ourselves that we want to get that t by itself, but I'm also going to box the square root as a reminder that I want to get the square root by itself. All right, I cannot get rid of a square root until the square root is all by itself. All right, so what two things am I going to have to get rid of to get the square root by itself? The 3 and the 4. All right, how am I going to get rid of the 4? How am I going to get rid of the 4? Subtract 4. How am I going to get rid of the 3? Divide by 3. So we're going to get rid of the 4 by subtracting. We're going to get rid of the 3 by dividing. Which one should I get rid of first? The 4. So how do I get rid of that 4? We're going to subtract it. So we're going to subtract 4 on the left, which means we also have to subtract 4 on the right. And on the left side, when those 4's cancel, what does that leave? Three square root of 7t minus 3. So everything that didn't cancel, which is everything but the 4, is just going to come down. All right, on the right side, what's 19 minus 4? 15. So we get 15 on the right side. And to finish up this step, what else do I need to do? Put the equal sign. All right, so once I subtract 4 from both sides and I simplify everything, I get a new equation. All right, and now we want to solve this equation. Now, when we boxed the square root, we saw that the 4 and the 3 were both outside the box, so I still need to get rid of that 3. How am I going to get rid of 3? We're going to divide by 3. All right, so we divide by 3 on the left, we divide by 3 on the right, and when we divide by 3 on the left, what's going to happen? The 3's cancel, and what does that leave? Square root of 7t minus 3. All right, and on the right side, what's 15 divided by 3? 5. So we get another new equation. Okay, so we're getting rid of stuff one at a time, and every time we get a new equation. All right, now what do we need to get rid of? Can I get rid of the 3 here by adding 3?
Yeah.
I'm hearing most people say no. Why not? Why can I not get rid of the minus 3? Because it's inside the square root, right? So I can't get rid of anything that's inside the square root until I get rid of the square root. And how am I going to do that, Carl?
Square.
We're going to square it. So to get rid of a square root, we square it. Remember, squares go up and to the right. Don't put the square anywhere else because then it doesn't mean the same thing. So we square the left side, which means then we have to square the right side. All right, so again, we're going to have some stuff cancel here. The square root and the square cancel, which leaves what? 7t minus 3. So we're just left with what was in the square root. And then on the right side, 5 squared is 25. All right, now what? Okay, now we're just solving like we normally do. So we add 3 to both sides to get rid of the minus 3. And when those 3's cancel, what does that leave us? 7t equals 28. And then I need to get rid of the 7. Divide by 7. All right, and then those 7's are going to cancel, leaving t equals 4. Kind of a lot of work, a lot of steps, but as long as you do each step in the correct order, you should be fine. All right, so when we started this, we had 4 numbers and a square root we had to get rid of, so that was actually 5-step equation, so we did 5 steps. And we got t equals 4. All right, let's look at this one then. This is a new one. We are going to start this one the same way as we usually do. So we circle the variable, Draw our line of equality. And I want to get the u by itself. So there's two things I'm going to have to get rid of. What are they? The 4 and the 2, the square, right? So I'm going to have to get rid of the 4. I'm going to have to get rid of the square. Which one of those two things do you think I should get rid of first? The 4. So if you remember order of operations, PEMDAS, when we're getting rid of a square, that's getting rid of an exponent. So that's going to be one of the last things we get rid of since we're doing it in the reverse order. So we are going to get rid of the 4 first by subtracting 4. Most people I saw did that. Okay, when the 4's cancel here, what's left over here on the left side? U squared. So we just bring that u squared down. And then on the right side, 13 minus 4 is 9. All right, so now we need to get rid of the square. How are we going to do that, Carl?
Square root.
Exactly. So the inverse of a square is a square root. Now this one's going to be a little trickier, and we'll talk about why in a second. But let's go ahead, let's simplify this here. What's going to happen with the square and the square root?
They cancel.
They cancel, and what does that leave?
You. Just you.
Just u. And on the right side, what's the square root of 9?
3.
3. Now, this is not the only answer. This one's a little tricky, but let's go back a step here. So we know u equals 3. I want to go back to what we had right here. This says that if I take some number and I square it, I'm going to get 9. Okay, and we said u equals 3. Does that work here? Is 3 squared equal to 9?
Yeah.
Yeah, because 3 times 3 is 9. There's another number that I can square and get 9. Does anybody know what it is?
18. 81.
We know that if we multiply positive 3 times positive 3, we're going to get positive 9. That's what we want. But we also know that if we multiply a negative times a negative, we get a positive. So what other number here can we square that would give us a positive 9? Negative 3. Because negative 3 times negative 3 is positive 9. All right, so anytime we're solving an equation that looks like this, that has a square equals some positive number, you actually get two answers. You get the positive answer, the square root of 9, which is 3, but you also get the negative answer. All right, so I'm going to throw this back up here. So here's what we did. We took the square root of both sides, and on the left side we get u, and on the right side we get 3, but it can also be negative 3. So what we're going to do with these problems, and this is, like I said, this is a little bit trickier because when we have squares you get two possible answers. What we're going to do is we're going to write another answer off to the side where u equals negative 3. So anytime we have a square, there's going to be two possible answers. And we want to make sure we put both of them down because u could be positive 3 or u could be negative 3. So we're going to put both of those as our answer and put boxes around both of them. This is probably the trickiest thing we're going to see when we're solving equations. It's the only thing that's not perfectly straightforward. But we do want to make sure that when we're solving equations, we give any possible answer that would be correct. So if I took this 3 right here and plugged it in for u, I would get u squared plus 4, and that would equal 13. But if I put the negative 3 in there for u, that would also work. There are no other numbers that would work, so these are going to be our two answers. Let's move on to the last one here. To simplify the square root of 360, what's the first thing we're going to do? Factor tree. I'm going to, since it ends in a 0, I'm going to do 10 times 36. You may have done it a different way. If you did, that's fine. Once I have the factor tree, what are we going to do next? Not yet. We can't circle pairs yet because we don't.
Make a little square root thing and then put all the numbers.
Okay. Yep. We're going to rewrite it. So instead of the square root of 360, we're going to have the square root of, looks
2
like.
times 2 times 2.
Okay.
Times 3 times 3.
Okay.
That's 5.
Good. All right. So we've got 1, 2, 3 2s. We got 2 3s, and we've got a 5. All right. So everything's in there. Now what? Now we're going to circle pairs. So we have a pair of 2s and a pair of 3s, and that's it, right? What's going to happen with those pairs? They go on the outside. And remember, they go on the outside because this 2 times 2 is 2 squared, and the square cancels out the square root, so that goes on the outside. And same thing with the 3, that's 3 squared. So 2 times 3 on the outside is 6, and then what's left on the inside? 10. For some of the problems we're going to do when we solve equations that have squares in them, we're going to end up with numbers or answers that might look like this, where we have to simplify a square root rather than getting a whole number answer.